When it comes to modern software, complexity is pretty much public enemy number one. As our systems stretch out from the cloud all the way to the edge, they get tangled up into these webs that are they're fragile and a total nightmare to manage. So today, we're going to dig into a technology that was built to untangle that exact mess and give us a simpler, much more powerful foundation for whatever's coming next.
So does this look familiar? Yeah, if you're trying to juggle microservices, cloud deployments, and edge computing, this slide probably hits a little too close to home. It's this constant struggle where every single connection is a new potential point of failure. But here's the thing, it really doesn't have to be this way. There's a much better approach.
Today's systems, they are a completely different beast. We're in this hyper-connected world, right? And that means our backend services and all our data streams need to be just as mobile and location-independent as our users are. And that creates a whole new pile of challenges around things like dynamic discovery, resilient communication, and, maybe most importantly, security. And here's the real problem. Our tools just haven't kept up. Technologies like HTTP and gRPC, well, they were designed for a much simpler time, for backends that were relatively static. In today's super dynamic, edge-heavy world, using them is kind of like trying to fit a square peg in a round hole. Their basic assumptions are being stretched to the breaking point, and you can really start to see the cracks. Okay, this slide just lays it out perfectly. The old way, over on the left, it locks you into these hard-coded connections using specific IP addresses in a one-to-one pattern. Now, to make that actually work at scale, we're forced to pile on all these extra layers of complexity: load balancers, service meshes, sidecar proxies, the whole shebang. But the NATS way on the right, it uses this flexible subject-based addressing, which means it can do a many-to-many pattern right out of the box. And the result? It's a radically simpler and way more elegant architecture from day one.
And this is where NATS enters the picture. It's not just another messaging queue. It's a totally new kind of connective technology, and it was designed from the ground up to solve these exact problems we see in modern distributed systems. So what do we even mean by connective technology? Well, think of it like the central nervous system for all of your applications. It's that fundamental layer that handles how your services find each other and how they talk to each other, how they send those signals, whether it's just a simple request or a continuous stream of absolutely mission-critical data.
So what's the secret sauce? What makes NATS so powerful for these modern systems? Well, it all comes down to a few core superpowers that really truly set it apart. Let's check them out.
First up, effortless many-to-many connectivity. So instead of a service calling a specific hard-coded address, it just publishes messages to a subject. It's kind of like a radio station broadcasting on a specific frequency. Any service that's tuned into that subject gets the message. This means any number of publishers can talk to any number of subscribers, totally naturally, without any complex routing logic.
Superpower number 2, you can deploy NATS literally anywhere. I mean it, on bare metal servers, inside virtual machines and containers, orchestrated by Kubernetes, or even running directly on tiny little edge devices. This incredible flexibility means NATS adapts to your environment, not the other way around.
And number 3, and this is a big one, NATS is secure by default. This is a massive advantage, especially when you're moving services out to the edge. NATS has this really robust built-in security model that's based on public key cryptography, which means it doesn't have to rely on traditional network firewalls, a model that, let's be honest, completely breaks down in distributed, multi-cloud, or edge setups.
But wait, there's more. NATS is more than just a simple messaging pipe. It gets that not all messages are created equal, so it offers different qualities of service to match exactly what you need, starting with its incredibly fast foundation, Core NATS.
So Core NATS is the bedrock. It gives you at most once delivery, which is this super high-performance fire and forget model. It'll do its absolute best to deliver a message, but it doesn't guarantee it. By keeping everything in memory, it achieves just incredible speed. This makes it perfect for things like telemetry or real-time signaling, where performance is everything and losing a random message here or there is totally acceptable.
But what if you absolutely, positively cannot afford to lose a single message? For those mission-critical situations, the ones involving financial transactions or vital system events, NATS has a powerful built-in solution for that. It's called JetStream.
This table really lays it all out. JetStream extends NATS with persistent streaming, and that bumps up the quality of service to at least once or even exactly once delivery. And that, my friends, unlocks a whole new world of possibilities, from reliable event sourcing and building stateful services to even creating key value and object stores right on your connectivity layer.
It's pretty amazing.
All right, let's talk about how all this helps you build a system that's truly future-proof. Because adopting NATS isn't just about solving today's problems, it's about setting up your entire system for whatever comes next.
I love this analogy. Think about your phone. It seamlessly switches between cell towers as you drive down the road, and you never even notice, right? You don't have to reconfigure your phone or reboot it. So why should our applications be any different? With NATS, your client apps are completely decoupled from the server infrastructure. You can add, remove, or reconfigure servers on the backend, and your applications never miss a beat.
This unique blend of simplicity, performance, and resilience means you see NATS popping up in a huge range of places. It's powering microservice communication in the cloud, running command and control for massive IoT fleets, handling high-throughput data streaming for AI and machine learning, and even augmenting or totally replacing clunky old legacy messaging systems.
This quote just nails it, doesn't it? The old ways of connecting systems simply were not designed for the unified world of cloud, edge, and IoT that we're all trying to build today. They're going to fall short. NATS, on the other hand, was purpose-built for this new reality. It just works.
So, I'll just leave you with this question to chew on. As you look at the systems you're building or the ones you're maintaining, ask yourself, is the foundation you're building on really ready for the future,